Okay, chapter 16, problem 10. Much of this problem is really about just understanding the equation. So here we have the equation for the amplitude of a transverse wave traveling along a very long string. Part A is, what is the amplitude? Well, the amplitude is this multiplicative factor out front. So the amplitude, just put it as y max, is 6, right? That's the amplitude. That turned that to euros. That's an E. All right. The wavelength. Okay. So where do we find the wavelength in this? Well, the wavelength is here in this factor that multiplies position. All right. So the wavelength is, if we have 0.020, let me do this, K, which is the propagation constant, 0.020 pi, right, is 2 pi over the wavelength, lambda, right? So if we just solve for the wavelength, lambda, it's just going to be 2 over 0.020. So lambda 2 over 0.20, I should be able to do this in my head, but I'm going to be lazy because, well, that's what, 100, 2 over 0.02002, oh, equal sign, it's 100. Yes, got there. All right, so wavelength is 100. I'm going to presume this is meters. Our x and y are expressed in centimeters. Okay, 100 centimeters. All right, put our units here, 6 centimeters. Okay, the frequency, right? Frequency comes from the term that's the multiplier to the time, right? So we have omega, get in math mode, omega is 4.0 pi, which is 2 times pi times the frequency, right? So this means the frequency is 4.0 over 2 is 2 hertz, right? 2 per second. Okay, that's the frequency. D, the speed, right? Right? D is the speed. So what is the speed of this wave? Well, derivative position of the wave with respect to time, right? Derivative position of the wave with respect to time. Well, we know for all of these, the wave velocity is lambda f. So in this case, we've got 100 centimeters, right, times 2 hertz is 200 centimeters per second, which is 2 meters per second. All right, that's the wave velocity. Speed, direction of propagation of the wave. That is easy. That's going to be to the left, all right, i.e. toward negative x. All right, and that's all because of this sign right here. It's a plus sign, and that is for a wave traveling in the negative direction. The maximum transverse speed of the particle on the string. Maximum transverse speed of a particle on the string. So now we're talking about when the string is going back and forth and back and forth. How do we find the transverse speed? Right? How do we find the transverse speed? Well, what is the transverse speed, right? It's the velocity in y. What's the velocity in y? dy dt, right? So dy dt with respect to time, at any given position. So we're just going to pretend we're at x equals 0 for this, because that'll make life a little bit easier. So dy dt, so 4.0 pi, derivative sign is the cosine, times 4.0 pi, so 6.0 times 4.0 pi times the cosine of 0.020 pi x plus 0 pi t. All right. Okay. And evaluate this. The maximum, we'll take x at x equals 0 times t equals 0. So the maximum velocity for this, right? The maximum is going to be when x and t are 0, Vy max. All right, 24 pi meters per second. All right, 24 pi meters per second. Okay. And what's the last little bit? That was F. What is the transverse displacement at 3.5 centimeters? Okay. G. 3.5 centimeters when t is 0.26 seconds. Okay. So this is just asking us to put in 3.5 and 0.26 for x and t. So I'm going to copy this. Y is, okay, for x, 3.5, right? And then for t, 0.26. All right. Equals 0.020 times pi times 3.5 plus 4.0 times pi times 0.26 equals the sine of all of that equals 6 times that, so minus 2.03 centimeters. And there you have it. I believe we're done. All right, that's it for problem 10.